Hello, welcome to the Rainbow Dash Template tutorial. Here you will learn about the Rainbow Dash templates. This video will introduce how to implement the effect of the toxic water mechanism. Alright, let's get started. In the template, the toxic water mechanism is made up of a part with decals and some effects. After the game starts, the toxic water mechanism will cycle between ascending and descending. When the player falls into the toxic water, the player will be teleported back to the last checkpoint. After understanding the components and effects of the toxic water mechanism, let's start by building a toxic water mechanism. First, a game region, where the toxic water mechanism will be placed has been prepared in advance in the scene. Next, we place a cube part in the region. Adjust its size, position, and transparency. Check its anchor property. In the Game Resources view, select the part. Change the name of this part. Click the Add button to the right of the part name to add a decal and some effects to the part. Drag the prepared decal and effects into the corresponding decal properties and effect properties. In this way, we have completed the construction of the toxic water mechanism. You can design the style of the toxic water mechanism according to the content of your game. After the game starts, the toxic water mechanism will cycle between ascending and descending, and stop for a period of time, when moving to the highest or lowest point. Let's first implement the logic for the ascent and descent of the toxic water mechanism. Click Game Settings, select Triggers and Scripts, click Server Script Management. Create a new server script and change its name to Toxic River. Double-click the script to open the script editor. First, define the module Toxic River. Next, define some variables. The part variable is used to store the toxic water mechanism obtained from the scene. The max position variable is the highest position of the ascending toxic water mechanism. The min position variable is the lowest position of the descending toxic water mechanism. The initial position variable is the initial position of the toxic water mechanism. The speed variable is the speed at which the toxic water mechanism ascends and descends. The next position variable is the target position of the movement. The interval vector variable is the distance that the toxic water mechanism moves per frame. The timer variable holds the timer object created. Then, define an externally accessible startup function, and pass a map parameter to it. We can call the find_first_child function from the root property of the map parameter to get the part with the specified name. After obtaining the toxic water mechanism, use the world position property of the part to initialize the position of the part. In order to make the toxic water mechanism move down first after the game starts, you need to assign min position to next position. To get the distance that the toxic water mechanism moves per frame, we need to use the difference between the target position and the current coordinates of the toxic water mechanism, normalize it, and then let the normalized result be multiplied by the set speed. Finally, turn on a timer and define a local function as the timer callback per frame. Next, we handle the logic for moving the toxic water mechanism in this callback function. To make the toxic water mechanism move, we just need to make the current coordinates of the toxic water mechanism increase by one vector value per frame. And this vector value is the interval vector. When the toxic water mechanism moves to the lowest or highest point, we have to make the toxic water mechanism move in reverse. To achieve this effect, you need to determine whether the toxic water mechanism has reached the target location. Use the distance function of vector 3 to get the distance between the target position and the current position of the toxic water mechanism. Then determine if the distance is less than a certain value, for example, 0.1. If this condition is met, we assume that the toxic water mechanism has reached the target location. Otherwise, the toxic water mechanism does not need to change the direction of movement. To change the movement direction of the toxic water mechanism, you can determine whether the current target location is the lowest point. If it is the lowest point, then modify the target position to the highest point position. Otherwise, the target position is the lowest point position. After setting the target position, we need to update the distance that the toxic water mechanism moves in each frame, so we can copy the code that we use to get the distance that the toxic water mechanism moves in each frame. If the toxic water mechanism does not reach the target location, then let the toxic water mechanism continue to move in the current direction. Save the code and open the server's main script. Use the require keyword to load the toxic river module. Use the getStaticMap function of the world class to get the current map. In order to avoid the game object from not being fully loaded when the players enter the game, causing us to be unable to get the toxic water mechanism parts, we can start a timer and wait for 160 frames before calling the toxic river module startup function. After completing the code, go back to the editor, run the game, and check out the results. You can see that the toxic water mechanism is starting to ascend and descend. When the toxic water mechanism is at the highest or lowest point, it needs to wait for a while before it can start again. To implement this logic, you need to define two variables first. The max position stay time variable is the time that the toxic water mechanism stays at its highest point. The min position stay time variable is the time that the toxic water mechanism stays at its lowest point. For the scripts on the server, the editor specifies that 1 second is equal to 20 frames, which means that if the toxic water platform once stays for 3 seconds, then it should stay for 60 frames. The delay property of the timer indicates the duration of each interval of the timer, in frames. When the current position is the lowest point, the toxic water mechanism will stay for 40 frames. When the current position is the highest point, the toxic water mechanism will stay for 60 frames. In order to avoid the increase in interval of the timer during the movement of the toxic water mechanism after changing the delay property of the timer, we also need to change the delay property of the timer to 1 when the toxic water mechanism moves. Save the code, go back to the editor and run the game. Now you can see that the toxic mechanism stays at the highest and lowest points for a while. When the player falls into the toxic water, the player will be teleported back to the last checkpoint. This is actually a collision between the player and the toxic water mechanism parts. The editor provides two functions for registering collision triggers, namely, the register handler function and the add handler function of the trigger class. The difference between the two is that the register handler function overwrites the existing triggers with the same trigger name, while the add handler function saves all the triggers with the same name in the trigger queue, and calls the triggers saved in the trigger queue in turn. When activated, you can choose the appropriate function according to the content of your game. Here we choose the register handler function. The register handler function has 3 parameters. The first parameter is the configuration information of the activated trigger object. Here we get the player's configuration information through the entity getConfig function. The second parameter is the trigger name. Here we use the trigger when the entity starts touching the part. The third parameter is the callback function to be executed after the trigger is activated. For more information, you can check the API documentation on the official website. The trigger callback function has one parameter. The object1 field of this parameter indicates the object that activated the trigger, which in this case is the player. The part field of this parameter indicates the part that collided with the player. We need to first determine whether the collision parts are toxic water mechanism parts. If the condition is met, then set the player's coordinates to the checkpoint location. To set the player's coordinates, use the setPos function of the player object, with a vector3 type coordinate data as the parameter. Since we didn't design the checkpoint logic, we can just pass in a coordinate to test the logic. Organize the codes, declare a local function, put the collision logic into that function, and call that function in the startup function. Save the code, go back to the editor and run the game. You can see that when the player falls into the toxic water, the player will return to the starting position. This is all the content of this video. I hope this content can help you make better games. To learn more about the content related to the Rainbow Dash template, you can leave a comment below the video, or post it on the official forum. See you in the next video.